Yeah. Yeah, and in fact, that's exactly right. And in fact, it can be self-defeating to tax beyond some point, right? So as you tax more and more, people are going to work less and less. At some point, you'll actually be earning less revenue that you can redistribute to the poor than you would if you had charged a lower tax rate. So clearly you don't want to do that, right? That's crazy. So there's a trade-off there. If you tax more, you're able to redistribute more. But on the other hand, you'll actually reduce the amount of revenue you earn to some extent because people will work less. This is called the equity efficiency trade-off. The more unequal society is, the more we want to tax and redistribute. But on the other hand, that's going to become self-defeating at some point because it reduces the amount people work. Yeah, Rashan.
Does the mechanism behind this, like, when there's the same, like, when monopoly tries to...
What?
Does the mechanism, like, we used to do something like this, is like the same concept, even like when a monopoly is setting prices?
This is it's exactly the same as monopoly. I mean, what we're gonna study today is basically one problem will be exactly equivalent to monopoly for the super rich, and for average people it'll be a monopoly that partially internalizes the welfare of the people that it's charging to. So the rich are just like a monopoly because we say we don't care about the rich. We just want to get as much revenue out of them as we can. Then it's exactly the same as the monopoly problem. When we think about the tax rate on average people, we have to take into account the fact that we partially care about their welfare. And so it'll be like a monopoly, except we'll partially internalize the surplus of the consumers. Okay. So our goal is going to be to maximize average utility, given that, first of all, we're only going to use this simple linear tax plus a surcharge on the rich. Right? Second, when we raise taxes, that's going to reduce the amount people work, and we have to take that into account. And third, we're going to take all that revenue and we're just going to give it back lump sum to everyone. We're going to ignore exactly which government programs we use. We're going to imagine we just write everybody a check for that amount of money. And we're going to ignore income effects. That is, if we write everybody a check, well, now they might work less because now they, have a higher income and they feel less need to work hard. We're just going to ignore that because the studies that have been done have shown that that doesn't really change the numbers very much, and it makes the formula a bit messier. But if you want to include that, you can go look at the Saya's paper in your readings, and it does that. Okay. Now, the reduction in work that people do when we raise taxes can therefore be captured by what's called the labor supply elasticity. That is, when people's wages change, how much do they reduce how much they work? So in particular, how much does the amount that people work fall in percentage terms when their wages fall by 1%? And in particular, we're going to capture that by the idea that if someone is earning income I, different people earning income I might have different labor supply elasticities, right? But we're going to say that the average person earning income I has a labor supply elasticity E bar of I. Okay. Then, what is the income that people get after taxes and transfers? Well, they get to keep 1 minus t times the income that they earn, I. But then, they get back as a lump sum the average income times the tax rate. Right? Okay. So, people's post-tax wage is their wage times 1 minus the tax, right? Because they only get to keep 1 minus the tax times their wage. Now, where's Botat? Botat. If the tax rises by a percentage point, how much does that cause that post-tax wage to fall by in percentage terms? You can work it out on the board if you want. Yeah. Yes, you have to divide it by the current wage, right? Exactly. So, and then can you just do the calculation? It's quite simple. Exactly. Did everyone follow that? So you just took the derivative of the wage with respect to the tax times 1 over the pre-tax, post-tax wage, and that gave you negative 1 over 1 minus t. So what that means is if we ask how much does the average income in the population fall when the tax increases, by what percentage does the average income fall when the tax increases, then what we can do is we can say we're going to integrate over all the different income levels, the income that those people are earning times the percent by which they reduce that income, which is the average elasticity, times how much their wage falls in percentage terms, times, there should be a negative sign here, by the way, times the number of people earning that income, right? That we take the integral of that and we divide it by the average income. Just the integral of the income, and that gives us that the average income falls by the average income-weighted elasticity, that is the average value of epsilon bar averaged over all the income levels. Let's call that just epsilon bar over 1 minus the tax. That's how much that's the percent by which the average income falls when the tax increases. And F here is the density of people earning that particular income. Okay. So now I'm going to ignore income effects coming from the lump sum transfer. So I'm going to act as if the, yeah, go ahead.
Is that a percent too?
What?
Is that a percent too, the average income fall?
Yes, this is the percent by which, or the fraction by which it falls. Yeah.
Why does it give us how much income falls when we multiply the elasticity of labor supply times negative 1 over 1 minus 2? Shouldn't that give how much labor supply falls?
Yes, but the point is that if someone's earning a constant wage, if their income falls by a certain percent, that's exactly the same percent by which their income falls. Right?
Okay, so labor supply and income fall by 1%.
Yeah. I mean, that's sort of what I mean by labor supply. It's like how much you get. Yeah, it's how much you get. Okay, so the total welfare in society is the integral over all people of their own welfare, which is the log of their income, right? Because we assume logarithmic income, times the number of people there are like that, right? And their income, again, is the weighted by 1 minus t average of their personal income and the average income in society. Okay. And as I was discussing earlier, by the envelope theorem, we can treat each individual as if when we increase the tax, they keep their income constant. That is, the harm that's caused to them by the increase in tax is exactly equal to their income. It's just how much they have to pay, right? And that makes sense. If you think how pissed off would you be about an increase in taxes, it would be how much you have to pay in taxes, right? Okay, so now what we have is exactly like a monopoly problem, right? We've got two effects. As we raise the taxes, we're going to increase the amount that we're getting. But it's also going to discourage people from working. That's like as we raise the price on a product, that reduces the quantity we sell. But there's one additional effect here, which is we actually care about the people we're charging the price to. So we're going to partially internalize consumer surplus, but only to the extent that we care about those people. And the problem is we care less about rich people than poor people, so the people who the tax hurts, we care about less than the average, right? And so that's what's captured in this equation. If we just take the derivative of this, right, we get a negative I term. So we get 1 over this, right, because that's people's marginal utilities. that's the weight that we put on giving $1 to a given person, is 1 over their after-tax income. So that comes out here. And we get minus their income, because that's how much they pay in taxes. And then what do we gain? Well, each person, if the tax goes up, gains the average income times 1, because that's what we managed to tax out. But then we're going to lose some revenue as well, right? Because the current revenue we're earning is tax times the average income, right? If average income changes by epsilon bar over 1 minus t, then we lose revenue equal to t times epsilon bar over 1 minus t. Right? Okay, so if we now integrate this out and we call 1 over this person's income the welfare weight we place on them, that's how much we value giving $1 to them relative to giving $1 to anyone in the population. That gets us this expression, which is 1 minus t epsilon bar over 1 minus t times the product of the average income and the average welfare weight minus the average of the product of them. And you probably remember from your statistics course that the difference between the average, the expectation of the product, and the product of the expectations is the covariance. Right? And so we can rewrite this expression, I bar times W bar minus the product of the 2 bar over those two as the covariance normalized by the average income and the average welfare weight. And that I'm going to call sigma of t. That depends on t. Why? Because, well, so first of all, what is this thing? It's a very natural measure of inequality, right? To the extent that, like, some people are really rich, and those people I'm going to put very low welfare weight on, and other people are poor, and I'm going to put high welfare weight on, there's going to be a very strong negative covariance between income and welfare weight. If everybody is exactly the same, then there's going to be no variance here, and therefore definitely no covariance, right? So this is just a very natural measure, very similar to the Gini coefficient of the inequality in society. Okay. So this equation is wrong up here. I'm sorry about that. That equation, you should just look at this equation here. If we then solve that out for t, we get t star is equal to sigma over epsilon bar plus sigma. And again, sigma is always positive, and it measures the degree of inequality. Epsilon measures the extent when we raise taxes to which people reduce the amount that they're working, right? And thus, we see that the optimal tax increases in sigma. The more inequality, the more tax you want, and it decreases in epsilon, right? As epsilon increases, this denominator gets bigger, and the optimal tax goes down. And Amanda, how does that capture the equity efficiency trade-off we've been talking about? What?
So increasing tax and declining epsilon. So like, it's more efficient. I don't know.
Did anyone else want to try? Yeah, go ahead.
Tax is directly proportional to sigma, which makes sense because tax goes up when inequality goes up. And it's inversely proportional to elasticity because the efficiency goes down because you're having the labor supply more elastic.
Exactly. So sigma is exactly a measure of what the equity efficiency trade-off is the more inequality there is, the more redistribution we want. The less inequality, the more inefficiency there is, the less redistribution we want. And that's exactly what this says, right? And so this is a super simple formalization of the equity efficiency trade-off. And notice how similar this is to the monopoly formula.